Anjini Karthik, and this is my Sigma Psi presentation. Each year, almost 2 million people die worldwide from the consumption of contaminated food and drink. And it's not just a problem in other countries. In America itself, 1 in every 6 people suffers from illnesses due to contaminated food and beverages. Food-borne disease results in thousands of hospitalizations, death, and significant financial burden for companies who have to issue product recalls. The methods currently in place used by the USDA to check for food safety include cell culture, incubation, PCR assays, acid treatment, and liquefying the sample, among others, all of which take about 7 days to yield results. So there really is a need for a much simpler, more rapid and effective method to check for food safety. In my project, I developed a tool for the simple, effective, and rapid on-site detection of pathogens on surfaces like food using cell-imprinted polymers, also called CIPs, and I investigated conditions to optimize these polymers' production. A CIP can be thought of as an artificially synthesized receptor for a given target molecule. It's produced by curing a pre-polymer in the presence of a template with a target molecule on it. The template is removed after the polymerization process, leaving behind specific binding sites that have a specific chemical affinity for the target molecule. So I tested varying pHs, 5, 7, 9, varying cell densities, OD2, 3, and 4, and levels of centrifugal force, meaning a radius of 5, 10, 15, 20, and 25 millimeters in template production, and hypothesized that varying these conditions would consequently affect the CIP cell count and surface coverage, important factors in assessing the CIP's quality. I produced templates for NCIPs for both E. coli and Salmonella enterica, and determined that optimal conditions for the production of a CIP were pH 5, OD3 for E. coli, and pH 7, OD3 for Salmonella. And actually centrifugal force levels, varying them had little effect. So the approach to pathogen detection that I developed and optimized is truly novel in that it dramatically cuts down results time to under 10 minutes as opposed to 7 days required by the USDA, and is a highly selective, disposable, and simple to use biosensing wipe with no sample prep required. So I truly believe that this kind of innovation can usher in a new paradigm for food safety management by helping to prevent microbial outbreaks and subsequently minimizing instances of foodborne disease throughout the world. In the future, I hope to make these wipes commercially available. Actually, they cost less than $1 a piece, so they can be used in developed and developing countries alike and minimize fatalities by curbing the outbreak of foodborne disease. Thank you.